All right, let's go ahead and get started. So the complex numbers can be defined as this. So let's start off with the definition. What is a complex number? All right, a complex number is any number that can be written in the form z equals a plus bi, where a and b are real numbers and I equals the square root of -1 is the imaginary unit. And let me underline complex number. There you go. Okay, so those are basically the complex numbers. You have z equals a plus bi. A is a real number, b is a real number, and I is an imaginary number. I is equal to the square root of -1. So let me start off with a fact. Here's a fact about I equals the square root of -1, and I squared equals -1. So I squared is always going to be equal to -1, okay? That is a major fact to know, so I'm going to put a box around it. Okay, so let's talk about real parts and imaginary parts. Real and imaginary parts. Okay, so z equals a plus bi. Has a real part. Let's just call it A. And it has an imaginary part. B. Okay, so when we talk about real and imaginary parts, what I basically mean is I'm talking about A and B, okay? As you know, A and B are going to be real numbers. So the real part is always going to be the A. Notice that the A is by itself over here. And then notice the imaginary part is B. And B is always attached to this I. That's how you know that the B is the imaginary part, okay? The imaginary part is always going to be attached to that I. So I'm going to draw an arrow to it. And I'm going to call it IM of Z. IM, that just stands for imaginary part. And I'm going to change my color to red. And I'm going to draw an arrow to the A. There we go. A is going to be known as RE of Z. RE of Z. So oftentimes when I write complex numbers, I'll actually use red and blue. And red will just stand for the real number or the real part. And the blue will always stand for the imaginary part, whatever B is. Okay? So let's keep on going with this. So if I have a real part I would say the real part of z is equal to a. And if I have an imaginary part, I would write it as Im of z is equal to b. So a is always going to be the real part, and b is always going to be the imaginary part. Okay, we're going to move on to complex conjugate. So what is a complex conjugate? We will learn that now. The complex conjugate of z equals a plus bi. So we have our complex number, a plus bi, and we're going to write it as z bar, which is basically just a z, but I'm going to write a bar over it like this. Z bar is equal to a minus bi. By switching the sign on the imaginary part. All right, let's try two examples like that. I'll give you guys a minute to get that copied down, and we're going to try two examples. So what have we learned so far? The real part is always going to be the part not attached to I, and the imaginary part is always going to be the number that's attached to the I. We call that the imaginary part. And for a complex conjugate, what you're going to be doing is you're going to be keeping the real part the same. So the a doesn't change when you go from a plus bi to a minus bi. The real part is always going to stay the same. But the imaginary part is actually going to switch sides, right? So if I give you a plus bi, you're going to give me a minus bi. But it also works the other way around, right? So if I give you a minus bi, if you switch the sign on this, what do you get back to? A plus bi, okay? So it depends, you know, if I give you a plus bi, you're going to change it to a minus bi. But if I started off negative, like a minus bi, you're going to switch back to a plus bi, okay? So all you're doing is you're switching the sign on the imaginary part. The b is going to switch its sign from plus to minus and from minus to plus. All right. Example. What is the real part of z equals 2 plus 3i? Imaginary part? Question mark? Okay, so go ahead and write that down. Go ahead and see if you can solve these two. And then while you're doing that, I'll be writing down the next example. Okay, so let's do a complex conjugate question. What is the complex conjugate of z equals 8 minus 6i? That'll be my next question. All right, take a minute on those and then we'll talk about them. All right, let me get my red pen out. So let's talk about the real part. What is the real part of z equals 2 plus 3i? Well, when we write the real part, we're always going to use RE of z. And the real part is always going to be not attached to the I. So it's going to be this 2 right here. Okay? Let me change over to the blue. We'll do the imaginary part. Okay, so what's the imaginary part of Z? It's always going to be the part that it's attached to the I, right? That's how you know that it's the imaginary part. So we're going to choose 3. Okay, did you get it right? Let's do the next one. What's the complex conjugate of 8 minus 6i? So when we write a complex conjugate, we're going to be using Z, but we're going to be using Z bar because we're talking about the conjugate. So I'm going to use a Z with a bar on top. So what is Z bar equal to? The real part is always going to stay the same. So the 8's going to stay the same right here. It's not going to change. But the imaginary part is going to switch its sign. So instead of being minus 6i, now it's going to be plus 6i. Okay, so that's the complex conjugate. You're just switching signs, really. Let's do one more like that. Find the complex conjugate of Z equals 3i. Go ahead and take a minute on that one, see what you can get, and then we'll talk about it. All right, what'd you get? Z bar. Now, you know I always switch the sign on the imaginary part, right? The imaginary part is 3. So I'm going to flip it to be a negative 3i. And that's it, negative 3i. Notice that the real part for this doesn't even exist. So we could say that the real part of Z is what? Well, since the real part doesn't exist, it's going to be 0, right? And then what's the imaginary part for this? The imaginary part would be 3. So now the imaginary part of Z bar, what would that be? Well, looking at this, a negative 3 is attached. So it's going to be a negative 3 this time. Okay? So that's real parts, imaginary parts, and conjugates. All right. Let's get to adding and subtracting. Adding and subtracting. Okay. So when we're adding, we're going to have A plus BI, and we're going to have another complex number. Let's call it C plus DI. All right, so I have 2 different complex numbers. I'm going to add them together. And the first thing I do is I put the real parts together. So what are the real parts going to be? The real parts are going to be A and C. So I'm going to start off by putting those together. So I get A plus C. And then after that, I'm going to put the imaginary parts together. So what are my imaginary parts? They're always connected to the I's, right? So it's going to be B and D. I'll underline those in blue. Okay, so those are the imaginary parts, B and D. I'm going to put those together over here. So B plus D. And then on the outside of the parentheses, I'm going to put my I, which is the imaginary unit. Okay? So that is adding. Let's try subtracting now. So let's say I have A plus BI, but I'm subtracting C plus DI. What are the differences that would occur? So the only difference is we're subtracting. So instead of doing A plus C, we're going to have A minus C. We take the real parts, we put them together, right? So A minus C. And then what would happen over here? The imaginary parts would go together, right? So let me underline those in blue. B and D. So it would be B minus D. And then I put my I on the outside. Okay? So we got adding, we got subtracting. Let's try an example with adding. Okay. Let's try 2 plus 3i plus 5 plus 9i. Okay. Go ahead and write that down and we'll try it together. There we go. So remember, when you do this, put the real parts together and put the imaginary parts together. All right, so I'm going to underline my real parts in red. And I'm going to put those together. So what's 2 plus 5 going to be? 2 plus 5 is equal to 7, right? Now, before I do the plus or minus, I'm going to grab my blue pen and I'm going to underline the imaginary parts. So where are my imaginary parts going to be? They're going to be attached to the I, right? So 3 and 9. So now we put those together. What's 9 plus 3? That's going to be 12. So I'm going to have plus 12i. Okay? So all you're doing is you're putting the real parts together and you're putting the imaginary parts together. That's not too difficult to understand. We're going to do another one just like that. Take a minute and try this one. Take a minute, see what you can do with that. And then while you're working on that, I'm going to put down the next problem. Okay, so I underline my real parts in red. That means the 6 and the -2 are my real parts. And then I underline my imaginary parts in blue. So the -3 and the +6. And I take care to underline that negative with it, because that's going to make it a -3, right? Okay, so let's put the real parts together. What's 6 plus -2 going to give me? 6 plus -2, that's 4. And then negative 3 plus 6, that's going to give me positive 3. Let's try a subtraction problem. I'm going to underline my real parts in red. And then my imaginary parts are going to get blue, as always. So what's going to happen here? What's 10 minus 3? Wouldn't that just be 7? So my real part is going to be a 7. But then what's my imaginary part going to be? What's 8 minus 6? Wouldn't that be 2? So positive 2y. We're going to do one more like that. Okay, take a minute and try this one. See if you can get the answer before I do. All right, so negative 1 plus 5, I'm only doing the red parts now. Those are my real parts. If I add those up, what do I get? You should get 4, right? And then I'm going to add up negative 1 and no, actually I'm going to do 3 plus negative 6. 3 plus negative 6. That's going to give me negative 3. So negative 3i. For this one, it was kind of tricky because I put the real part on the right side for this one. And then over here, it's normal just like all the others, right? It's that first complex number that trips you up. Okay? I'll leave that there for a few seconds so you can finish copying that down. And then we're going to move on to multiplying and dividing, which are a little bit more complicated, but not really. Okay. Go ahead and copy this down. And then we'll go ahead and try it together. Okay, so we got a plus bi and we have c plus di. So if we multiply these together, what's going to happen? Well, basically, this is actually going to be the FOIL method. This is going to be the FOIL method. All right, so when you're doing the FOIL method, there are 4 letters, right? There's an F, an O, an I, and an L. And all these letters stand for something. It's going to be first, outer, inner, last. So let's look at the first 2 terms. My first 2 terms are going to be, and maybe I should switch to red for this, A times C. A times C is going to give me AC. So that's what I start off with, my first two terms. I just go ahead and multiply those together. So those were the first two. What are my outer two? Well, my outer two are going to be what's on the outside, right? A and di. So I'm going to underline my d with a blue because that's an imaginary part, right? A times d is going to give me AD, I. The I comes along for the ride. And then what we're going to do is we're going to look at our inner two parts. So what are my inner two parts? It's going to be C and BI. I'm going to underline the B with blue because that's the imaginary part. So B times C is going to give me BC. I. BCI. Okay? And now I'm done with inner. Now I do last. So what are my last two terms? It's going to be these two, right? The blue ones. So what's BI times DI? That's going to give me plus BDI squared. BDI squared. Okay? So what do you see immediately? Excuse me for a second.
May I have your attention, please? All custodians, please come to the gym at this time. All custodians, please come to the gym at this time.
Okay. So what do we see about this immediately? Well, we got two imaginary parts. I'm going to underline them in blue. They occur in the middle, AD and BC. Notice how they're attached to I's, so I mark them with the blue. And these two are actually going to be my real parts, the AC and the BD. So how does this all work out? Well, the AC is going to come down just like it is. And then what I'm going to do is, once I take down that AC, I've got two middle parts that I'm going to put together. AD plus BC. And I'm going to put an I outside the parentheses. So my imaginary part is going to be AD plus BC. So now I've got my two middle parts worked out, but what's there at the very end? What's at the very end? A BD I squared. So plus BD. And then we need to figure out what I squared is. Well, do you remember our fact from the first page? Take a look at this. Remember when I told you I squared is equal to -1? See that right there? We already assumed that I is the square root of -1, right? So if we square it, it's like we get rid of the square root, right? So I squared is obviously equal to -1, okay? So everywhere I see an I squared, I can replace it with a what? A -1. That's right. So the I squared is going to get replaced by a -1, just like that. Okay? And then there's really only one more step to do. I'm going to do two more equal signs, and I'm going to put the real parts together, right? So what are my real parts? What are my imaginary parts? Again, AC, BD, those are my real parts. And then AD and BC, if I add those together, I get the only imaginary part, right? So let's put the real parts together. I've got my AC minus BD plus AD plus BC with an I at the end. So now can you see how the real parts come together? The real parts are actually at the ends, but the imaginary parts, they meet in the middle. So this whole thing is going to be my real part. And then whatever's attached to the I, that's obviously going to be the imaginary part, right? So I'm going to give this a blue. So let's see that in action. We're going to see an example of this. We're going to be doing 3 plus 2y, and then 5 plus 4i. Okay, I'll give you a few seconds to get that copied down, and then we'll try it together. All right, so let's do the first two terms. 3 times 5. So I'm going to underline those. 3 times 5 is going to give me what? 15, right? Now let's do outer. Where am I outer to? 3 plus 4i. That's going to give me 12i. Plus 12i. Okay? We've done the outer. Now we move to the inner. What are my inner two terms? 2i times 5. That's going to give me what? 10i. And then we do the last two terms, right? The 2i and the 4i. So I get plus, what's 4 times 2? 8. 8i squared, right? Because I have two i's going at this point. A 2i and a 4i, right? Okay, so now what we can do is we can put the middle two parts together. The 12i and the 10i, that's going to become a 22i, right? So 22i, and then plus 8i squared. Plus 8i squared at the end, okay? I know that I squared is -1, so I can replace an I squared with a -1 whenever I want. I replace that with a -1. So then what happens? I have 15 minus 8. Plus 22i. So all I did in this step was I just did 8 times -1. We know that that's going to be -8. So now I have two real numbers to add together, and I've got an imaginary part at the very end, right? So what's 15 minus 8? Or 15 plus -8? That would just be a positive 7. So you would get 7 plus 22i. Okay? And that's all FOIL method. So let's do one more like that, and then we'll move on to division. Okay. Now for this one, we have 3 times 5. That's going to give me 15, as usual. So what I'm doing is I'm multiplying my first two terms together. I'm multiplying the first two terms that I see. Okay. Then I move on to my outer, which would be a -3i times a 3. So what would that be? That would be -9i. That's my outer 2. Then I'm going to move on to my inner 2. Well, where's my inner 2? That's going to be the inside 2. -2i times 5. That's going to be -10i. All right. So then my last two terms are going to be -2i and -3i. Now, what happens when I multiply a -2 times a -3? You should get a +6, right? So I'm actually going to get a +6 this time. I squared, right? That I squared comes in because I have two i's right here. When I multiply those, I get I squared. So I do the middle two parts together first. I'm going to bring down my 15, and I'm going to do -9i minus 10i. That's -19i. So I'm putting those middle two terms together, right? And then this last part is actually going to be a -6. Why is that? Well, it's because I squared is -1. My I squared has been replaced by a -1, right? So this is actually going to be 15 minus 6. And then the minus 19i comes down. Okay, so I'm almost done. 15 minus 6, that's going to give me 9. Minus 19i. Bring down that minus 19i, and you'll be done. All right, so that's multiplying. We're going to get into division next, and then I'll be out of time, and I'll see you guys on Wednesday when I get done with this division. Okay, let's just do one division problem and maybe a practice one after that, just to give you a sense of how division is done. I'm going to choose the problem from my problem set, if I can find it. Yeah. Okay, let's do 3 plus 2i. That's my first complex number. And I'm going to divide it by another complex number, 4 minus 3i. Okay. So this time I'm dividing. So what's the numerator here? Well, the numerator is always going to be the top of the fraction, 3 plus 2y. So then what's the denominator going to be? It's going to be 4 minus 3i, right? Because I'm looking at the bottom of the fraction now. What I want to concentrate on is the bottom of the fraction. We're going to start off by multiplying by the bottom, but before we multiply by the bottom, we need to find the complex conjugate of the bottom. So what's the complex conjugate of 4 minus 3i? Well, I'm going to keep my real part the same. So I'm going to have a 4 on top and a 4 on the bottom. But for a conjugate, I have to flip the imaginary sign. Since the imaginary sign is negative, I have a -3. We're going to change that to a +3. So it's going to become a +3i and a +3i. So notice how I have the same thing on the top and the bottom. That's good. That's because I'm actually multiplying by 1. That's the secret. I'm multiplying by 1. So this is the complex conjugate. The complex conjugate. Go ahead and write that down so you don't forget it. This is the complex conjugate of the bottom of the fraction, right? That 4 minus 3i. So what's the secret here? I'm actually multiplying by 1. Multiplying by 1. Because the top and the bottom part are the same, they cancel out and give me 1, right? So we're actually going to be multiplying the top together and the bottom together. Let's see what that is. So I've got 3 plus 2i and I've got 4 plus 3i, right? That's on top. But what's on the bottom of the fraction? We're going to have 4 minus 3i and 4 plus 3i. And that's just because I'm putting the top two parts together on the top and the bottom two parts together on the bottom. So now we have a FOIL question. We have a FOIL question on the top and on the bottom. So doing the top part, we do the FOIL method, right? I do the first two parts together, which is 3 times 4. That's going to give me 12. I do the outer two parts together to give me a 9i. And the inner parts are actually going to give me 8i. And then the last two parts, that 2i and that 3i, that's going to give me plus 6i squared. Okay, so now that I'm done with the top, I'm going to move on to the bottom. I've got 4 times 4. That's going to give me 16. The outer two parts are going to give me 4 plus 3i. So that's going to be 12i. The inner two parts are going to give me negative 12i. And then the last two parts together, negative 3 times a positive 3, that's going to be negative 9i squared. All right, so let's simplify a little bit on the top. When I simplify on the top, notice how this 6i squared becomes a negative 6. So 12 minus 6 is going to give me 6. But for now, I'm just going to write it as 12 minus 6. Now, we can put the middle two parts together to get 17i, right? I'm just adding the I terms together. And then on the bottom, what do I get? Well, I've got that 16, so I've got to bring down that 16, right? It's just the real number 16. But what's happening over here with this negative 9i squared? Now, as you know, I squared is equal to negative 9. That is true. I mean, I squared is equal to negative 1. We know that I squared is equal to negative 1. But negative 1 times negative 9 is going to give me what? A positive 9. A positive 9. That's because I've got negative 1 times negative 9, right? Those two signs cancel out when you multiply. That's how I get that positive 9. And then the middle two parts together, I have 12i minus 12i. They actually cancel out. So there's no I part on the bottom anymore. You probably noticed that when I did it, right? I've got a positive 12 and a negative 12. They cancel out. So my final answer is going to be whatever's on top, right? What's 12 minus 6? That's going to be 6 plus 17i. And then what's going to be on the bottom? 16 plus 9, that's going to give me 25, right? And I'm done. That's division. We're going to do one more example like that, and then I'm going to call it a day. Let me leave that up there for a few seconds, and I'll just write down my next one over here. And while you're busy on that, what I'm going to do is I'm actually going to use a classwork question. Classwork. Okay. Okay, I think I'm ready for this. Okay. This is going to be classwork. So let me write classwork at the top. All right, so I've got a numerator, I've got a denominator. What I do first is I find the complex conjugate of the denominator. The complex conjugate is not 3 minus 2i, but 3 plus 2i, right? Because I'm changing the sign on the I term. That's basically all I'm doing. And I'm going to do it on the top and the bottom. So what happens with this? Well, I get two FOIL questions, right? I've got 2 plus 6i, and I've got 3 plus 2i. That's on top. But then on the bottom, I have 3 minus 2i and 3 plus 2i. Okay? So I'm going to do the math at the top kind of quickly. I'm going to use the FOIL method to do it. So I know that 2 times 3 is 6. The outer terms are going to give me 4i. The inner two terms are going to give me 18i. And then I got this 12i squared hanging off. All right, so that's the top part. What would the bottom part give me? Doing FOIL on the bottom part is actually pretty easy. 3 times 3 is 9. The outer parts are going to give me 3 times 2y, that's 6i. The inner parts give me the opposite, right? Did you catch that? Negative 2 times 3, that's going to give me negative 6i. And then my last two terms are going to give me negative 4i squared. So now, revising the top, here's what I get. 6 minus 12 plus 22i. Notice how that I squared at the end gives me a negative 12. And the I terms together give me a 22i. Looking at the bottom of the fraction, I have a different story. I have a 9. Negative 4 times negative 1 is going to give me what? A positive 4. That's why I have a 9 plus 4. And then I have 6i minus 6i. We know that's 0, so I don't need to write that. So what happens at the top? I have 6 minus 12. That would be negative 6 plus 22i. I bring down my 22i. And then what's at the bottom? 13, right? Lucky number 13. And then I'm done. So that is dividing on the classwork.